Good afternoon, everyone. Welcome to GRC316. I'm Rahul Gulati, and today we'll be talking about continuous compliance using AWS management tools. A bit about myself. I'm a product manager for AWS Resource Groups. With Resource Groups, you can create groups of AWS resources based on tags or other services such as CloudFormation. You can create logical groups that are associated with a particular workload, such as different layers of an application stack, or different environments, such as production or development environments. Once you create a resource groups, you can take bulk actions through Systems Manager. You can filter resources in other service consoles, such as DynamoDB, and you can gather insights using CloudWatch. Prior to resource groups, I was a PM for AWS OpsWorks, which offers fully managed services for configuration management engines like Chef Automate and Puppet Enterprise. This session's agenda is to discuss the need for compliance, the need for continuous compliance. We'll also get a high-level overview of DevSecOps. We'll look at demos of specific compliance engines, Chef InSpec, which is a third-party open-source compliance engine, as well as AWS Config, which is an AWS native compliance engine. Any well-architected application, be it big or small, stands on 5 key pillars: security, operational excellence, reliability, performance efficiency, and cost optimization. Since security is one of the key pillars of any well-architected application, let's take a minute to understand what is the AWS shared responsibility model. AWS shared responsibility model is between the customer and AWS. AWS is responsible for security of the cloud, and customers are responsible for security in the cloud. So AWS delivers security of the cloud, meaning it protects the infrastructure that runs all of the services offered in the AWS cloud. AWS operates, manages, and controls the components from the host operating system and virtualization layer down to the physical security of the facilities where AWS cloud and services operate in. On the other hand, customers are responsible for security in the cloud, meaning that you're responsible for applications, services, and packages that you're managing. You're also responsible for application software, configuration of your instances, and securing your instances by configuring firewalls through security groups. To give an example, if you are using an abstracted service like Amazon S3 or DynamoDB, AWS is responsible for the infrastructure layer, operating system, and platforms, while you as customers are responsible for data encryption or classifying assets using tags, or using identity and access management tools to apply appropriate permission groups. Now, there are a set of issues with the traditional approach to compliance. Firstly, it's point in time, meaning that teams swing into action weeks before scheduled audits. Secondly, expertise is not given to all. The needs of compliance frameworks are limited to a few security professionals inside an organization. And it's not shared with the other application developers and operators in your organization. That's what we have typically come across our customers. What this leads to is that it becomes time-consuming for everyone because it becomes an interrupt-driven approach instead of being like a daily regular approach. Hence, dedicated effort is required to maintain security of your infrastructure, and ultimately takes focus away from building core business value for your customers. The traditional approach is further complicated by compliance frameworks. You might be required to comply to a lot of compliance frameworks based on the industry that you operate in. For example, if you're into payments, then PCI is something that you might care for. If you're into health sector, then HIPAA is something that you might care for. If you're operating in Germany, then C5 compliance framework is something that you would care for. And here in the US, you might care for FedRAMP. Ultimately, all the standards are fundamentally the same. That is, they require a baseline of security controls for identity and access management, data protection, infrastructure, monitoring, logging, and incident response. And let's not forget, in the shared responsibility model, you as customers still have responsibility to maintain and secure your applications. While AWS controls the hypervisor and all the layers underneath it, you as customers are responsible for all the layers, all the application layers and things on top of it. Hence the need for automation, because anything done manually is not scalable, repeatable, reliable, and consistent as an automated process. Beyond a point, it becomes really hard to keep track of your resource inventory. It becomes pretty painful to track numerous compliance requirements in spreadsheets. So automate as much as possible and establish processes that scale as you expand your business and as you scale your infrastructure. The biggest drawback of not having continuous compliance and automation is that over time, the delta between where your infrastructure is today and where you want to be keeps on increasing. And this is bound to happen as compliance regulations are not assessed continuously. Over time, as you add more complexity to your applications, you introduce more microservices, you provision new infrastructure, the drift keeps on getting bigger and bigger. And that's where compliance engines come in. With compliance engines like Chef InSpec and AWS Config, you test your infrastructure and applications continuously, you build controls in your pipelines, and you establish drift detection and remediation. For a resilient security posture, and to stay on top of the desired state of your infrastructure, you need to establish automated processes and continuously check if you're compliant and regularly generate reports. Continuous compliance is unprecedented visibility and near real-time automation. With continuous compliance, you know who changed what, where did this change originate from. You continuously detect, remediate, and automate your applications and infrastructure. With continuous compliance, security is built in, not bolt on. Security is treated as a daily practice, not as an afterthought, and not as a one-off activity. And DevSecOps, like DevOps, is a change in mindset. Instead of worrying about or obsessing about which tools or services to use, it's about a mindset where developers, operators, and security professionals literally need to be on the same page. The goals of DevSecOps include that the pace of security automation matches the pace of innovation that is happening in application development and operations. Also, the second goal is that you scale security as you scale your infrastructure. You take actions based on risk, ratings, and severity, and then you prioritize remediation accordingly. So let me give you a high-level overview of how continuous compliance looks like. If you look at the top left, you have compliance as code rules. You would use any compliance engine and start describing compliance as code in the domain-specific language. Once you define compliance rules, a rule-based engine is going to start processing these rules. And whenever a change is made by a developer or an operator, the rule-based compliance engine picks up the triggers. And it figures out whether there is a need for a remediation response. And regardless of compliance or non-compliance, all the results are cataloged in a compliance dashboard. Once you have a catalog of compliance results, you can use SNS notifications to trigger emails, SMSs. You can send notifications to your favorite chat ops app like Slack, or send your notifications to a centralized ticketing tool like Jira. Now let's talk about Chef InSpec. Chef InSpec is an open source framework for testing and auditing your applications and infrastructure. It works by comparing the actual state of your system with the desired state that you express in code. You turn your compliance, security requirements, and policy requirements into automated tests. Let's look at an example. This is InspectExec, which runs all test files at a specified location. In this case, Linux baseline happens to be my profile that will contain a bunch of controls and tests, and I'm going to run it against a set of Ubuntu instances. So InspectExec, again, simply loads the given profile, fetches their dependencies if required, and then connects to the target instances and executes any control in the contained in the profile. The second thing that I'm going to do is I'm going to use resource groups to list group resources. The idea being that you have to treat your infrastructure like cattle and not pets, and you use a grouping service to fetch all the instances that you would want to remediate on or detect compliance on. Now let me switch to the terminal. So I'll go to the management console, And I'll find resource groups here. I'll create a group. I'll select EC2 instances that are tagged by name, called front-end Ubuntu app, and where the cost center happens to be team Reinforce. All right, so I'm creating a group that belongs to a particular cost center, that belongs to a particular environment, and it's of EC2 instance type. And I can see that I have 3 instances that meet this criteria. I'm going to give it a name. I'll call it front-end RG and list of all front-end servers. And now I've created a resource group. Now I'll go to the CLI and I'll show you a InspectExec profile. So that's how an InspectExec profile looks like. The key directory here is the controls directory that contains a list of controls and automated tests, tests that are described in Chef DSL, which is based on Ruby. And then there is an inspect.yaml. Inspect.yaml contains your metadata. Let me load that file. It contains a baseline description, what this profile is going to be. And next, I'm going to look at the controls. I'll go to the controls folder and load package-related controls. So if you notice that there are 3 different types of controls in here related to operating system, packages, and system controls. For this particular demo, I'm going to care about the package controls. And let's have a look at one particular control, wherein my compliance is described as code. What it's doing is it's basically saying that do not run any deprecated form of inetd or xinetd. There is a description which links to an NSA document, and it's Ruby DSL, which says these particular packages should not be installed. Next, I'm going to run a script that is going to detect compliance on a set of instances. Let me show you what's happening inside the script. And let me take you line by line. So what's happening here is that on line number 3, I'm querying resource groups and getting all the relevant resources that belong to this particular group, the group that I created earlier. On line number 4, I'm iterating through this resource group. And on line 8, I'm pinging EC2 describe instances to get the public DNS name. And then on line number 10, I'm executing Linux-based line against these particular instances. And if you look at ---- controls, which is helping me say that I'm only interested in these particular packages, do not run this entire control file because there are about over 100 controls in this particular profile. So I'm only worried about these 9 package controls. Let's look at the results. Now, this is the compliance summary. You can see a bunch of tests have passed. And there's one particular test which has failed, which is system package audit D should be installed, which is not installed in here. To remediate this, I'm going to execute another script, and I'll take you through it. But bear in mind that if you want to remediate, you can use any configuration management engine of your choice, be it Chef, Puppet, or Ansible for that matter. Now let's look at this particular script and what it does. So similar to the previous script, it's going through a set of resources that belong to resource groups. And if you look at line number 9 and 10, it's installing audit D on all the Ubuntu instances that I created a group for. You can see the command in there, sudo apt install -y audit D. And it's going to rerun the scan. Remember, in the previous scan, the results were failing. The compliance, there were 3 non-compliant resources that it found. Now, and after installing audit D, I'm going to rerun the scan again. And as you can see here, the package 8, which was failing earlier, now it has passed through. It says system package audit D should be installed. And this has gone through all the earlier instances that belong to this particular resource group. So there were 3 instances. On all 3, the results have passed, and now I have a compliance status. So we ran an inspect profile against a group of AWS resources. We found out that they were not compliant, and we remediated by installing packages on a resource group, and we validated the compliance status by running the profile again. Now, Chef InSpec works well if you care about compliance at application, services, and package level. But if you care more about at the AWS level compliance, wherein you want a more native tool which is fully managed by AWS, that's where AWS Config comes in. AWS Config provides AWS managed rules which are predefined yet customizable. Config rules evaluate whether your AWS resources comply with common best practices. To give you an example, whether multi-factor authentication is enabled for all my IAM users or not, there is a config rule to figure that out. Another example is, are my EBS volumes encrypted or not? Or are specific tags applied to my resources or not? So these simple AWS level compliance tests you can execute using AWS config rules. For this particular demo, I'll go to AWS Config. I'll go to Config Rules. There are a couple of rules in here. I care about DynamoDB autoscaling enabled. As the name suggests, this particular rule will check whether autoscaling has been enabled on my DynamoDB tables or not. And as you can see here, there are a couple of non-compliant resources, DynamoDB tables, that do not adhere to this particular rule. Next, I'm going to DynamoDB. I'll go to tables, and I see a couple of DynamoDB tables in here. And I'll create a group. I'll move all my tables to a particular group, give it a name called backend resource groups. And the resource group has been created. I'll go to the page just to verify if things are looking fine. And there is a group with a couple of DynamoDB tables inside it. Next, I'm going to run a script in here, which is config. All right, let's look at the script. So like the earlier example, what this particular script does is that it iterates over resource groups and enables autoscaling on each table. It not only enables autoscaling on each table, it also specifies target utilization, read-write capacity, as well as the scaling policy that is relevant for my tables. I run the script, enable autoscaling, and then I do a sanity check, which is on line number 15. AWS application autoscaling describes scalable targets, just to kind of verify whether everything has been applied correctly or not. And looks like it has gone through. Now I'll go back to config to verify the compliance status. Now, as you can see, Config has picked up the latest changes that have been made, because this you can see on the overall rule status in here, the last successful invocation and evaluation, and instances that were earlier in non-compliance are now compliant. So we ran an AWS managed rule that found non-compliant resources. We grouped those resources into resource groups. We remediated by enabling application autoscaling, and we evaluated results again and found compliance to be found our system to be compliant. So now let's review a few next steps for you to establish continuous compliance in your organization. First up, you have to start small and create a cloud security policy for one of your subsystems. It could be one particular application, one particular business unit, or one particular environment, such as a staging environment. But you have to start small and start at a very specific subsystem. Next, you're going to perform AWS service due diligence. You can do so by going to the AWS compliance page. You can find tens of AWS services that adhere to tens of compliance frameworks, and you pick and choose AWS services that fit your need. Next, you're going to perform similar due diligence on your compliance engines based on your needs. If you care more about control, then you might choose compliance engines that let you describe compliance as code. If you care more for convenience, then you might go for an AWS managed compliance engine. Similarly, if you care more about compliance of applications, servers, and packages, then you might choose a particular compliance engine. And if you care about AWS level and instance level compliance, then you might go for something like Config. Once you do that, we find a lot of customers are already using infrastructure as code and configuration as code. Not everyone is at the same level, but largely there is adoption amongst most of the customers. And then what you would start doing is that you would start creating automated patterns like the ones that I showed you, and you will start baking in compliance controls into your pipelines and into your application delivery. And the other thing that you should do is consider using services like AWS tags and resource groups that allow you to treat your infrastructure as cattle, not pets, where you can make changes in bulk at once. And that's it for this session. It's a wrap. Thank you so much for your time.